first of all. There is the function test. What is the test for a function, Nick Shanks?
I was going to tell you what a graph was.
I know what the graph is. What is the test for a function is what, Lucas? It's the vertical line test, where you remember if you have a graph of something, you take a whole bunch of vertical lines, and if that vertical line only crosses that graph only once in every line, then this is a function. We won't talk too much more about that. But we're going to look at the graphs of some stranger, more bizarre sort of things. Okay, you already know what the graph of this looks like. Y equals mx plus b. That's the generic form of a what? Does anybody know? No. This equation will give you, when you graph it, what? Does anybody know? A line. Exactly. This is a linear equation. Okay, it'll give you a straight line. We're looking at things today that are functions that don't necessarily give you straight lines. And they are the graphs of these things, and you just need to be able to recognize them. You don't really need to know anything more about it. For example, the first one we're going to look at is the y equals x squared graph. And I think we talked about x squared, did we? Did we do x squared before? Let's just make a table. Because really that's the only way you can do this here. Just to show you what it looks like. Does anybody remember what the graph of x squared was? Special name we called it. It is a U shape. It's called a parabola. The umbrella thing. Okay. It's a parabola. And just quickly to do that, let me just pick some numbers. -2, -1, 0, +1, and +2. If you square x, that's what you get for y. -2 times -2 is a +4, +1, 0, +1, +4. Just squaring all those. So if you graph that, here's what it looks like. 0, 0, -2, 4, -1, 1, and then you get the opposite, the integer bit here. So this is your parabola. Now, that parabola can be upside down or it can be right side up. It can be moved or shifted based on whatever's next to this x squared, but it will always give you a U-shaped thing or a N-shaped thing. Okay, so y equals x squared. Anytime you see something that looks like this, even if it was over there, okay, that is an x squared equation. Somewhere in that equation there'll be an x squared. Even if it was upside down, like this. As long as it's a parabola, whether upside down or right side up, it's going to have x squared in it. Yay. That's your first thing. And you just need to recognize that because I'll have you just match which ones go with which one. You don't really have, you won't be asked to graph it, I don't believe. Not yet. That comes in a little later on in your mathematical works. Nick Shanks?
Can you have a parabola that's like on a tilt?
No, because that wouldn't be a function anymore. Nick asked this question, and I'll erase this. Could you have a parabola like this? No, because your vertical line test would say can't do it because it crosses in two places. So no, you can't. Not at this point. Anyway, Jackson?
If you can see like the 3 dots and then you make a line and see that it's kind of like in a U kind of shape, could you always assume that it would be a parabola?
No. That's why if you were graphing something, you'd have to get enough points to make sure that it does that, because we're going to do some now that are what you said and don't do that. Lauren?
So a parabola always has to follow the vertical line test, so it can't be like suicidal.
Yes, if it's an x squared one.
Oh.
If you flip it around and make x equal to y squared, then you get the sideway one. And that's not, we're not talking about those, because that's not a function anymore. And we'll talk more about that. I don't want to, we could spend forever talking about the differences in that, and I don't want to go there, because it just isn't. Now, second one we're going to look at is this one. What about y equals the square root of whatever x is? What does the graph of that look like? This is graph number 2. Again, let's put a little table down here. Again, fortunately, we can pick numbers that we know so that we can get square roots of. What are some perfect squares that you could do? Well, I'll start you off with. You could have 1 because the square root of 1 is, it's been a long vacation, but the square root of 1 is 1. Square root of 0 is, square root of 4 is, square root of 9 is 3. Now, you can't pick, if you're given that equation, what can't you pick? You can't pick negative numbers. Why? Because you can't, it's impossible. Those are what we call those are not irrational, but they are the imaginary numbers. Okay? You cannot do this. You cannot have the square root of negative 16 because there is no number times itself that gives you that. That's where we get the imaginary numbers, and they come later on in your math things. Now, what will the graph of this look like? It's kind of exciting, I know. 0, 0 is right here. 1, 1, right here. 4, 2, 1, 2, 3, 4, is right here. 9, 3, 5, 6, 7, 8, 9, 1, 2, 3. This is the square root of x graph. It is this little shape that looks like this. Okay, it's kind of like the Nike swoosh kind of thing. Okay, and that's the same thing. Anytime you see this little thing that looks like that, I mean, whether it looks like, I guess I should do this. Here's your graph, and you see something that looks like this, you know that is a square root of x, or it has the square root of x somewhere in it. Okay, if it was moved over here somewhere, okay, square root of x. Depending on what's next to it, because you can have x plus, 4. If y equals the square root of 2 times square root of x plus 4, that changes where this little swish ends up, but it still ends up looking just like that. A little swishy looking kind of thing. Random.
But for the, supposed to never be in the, negative signs.
Well, it could be on the negative side depending on what's with it, I believe. Well, maybe it can't, because x could never be a negative number. Probably not. Let me look. I'm going to say right now I don't know, but maybe not. Can it ever be over on this side over here? Probably not, because you could never pick a negative number for x. So it'd have to be somewhere in this positive end of things on the x-axis. I guess this can't happen. That's a good question. Because you can't pick a negative 1 for x. Lucas?
But it could be like negative on the positive side. Right? Like, it could be in the bottom
Y could be
right corner.
negative. Y could probably be negative. Probably if you did this. Let's graph this. What if y equals the square root of x minus 6? Okay, if you were graphing that, and you did the same thing we just did and put in there 0, 1, 2, and 4. If you put 0 in here, you get negative 6 for y. If you put 1 in there, you get negative 5. If you put 2 in for, oh, I'm sorry, we don't do 2. If you do 4, you're going to get negative 4. If you do 9, you're going to get what? Negative 3 if you take those square roots. So when you graph this, 0, negative 6 is going to be down here. 1, negative 5 is going to be right here, and it's going to end up looking like this.
But could the square root of 4 also be negative 2?
No, you can't. No, you're taking the square of something. We can't take the square root of negative numbers. You're thinking about it backwards. That cannot be done.
No, the square root of 4. Negative 2 times negative 2 is 4.
Square root. I think we only go with the positives. Again, we're kind of on uncharted territory here. If you put negative 2 in there, what would you get? No, you have to go with the positives. Unless there's a plus or minus here, you always go with the positives. So just know that the square root symbol is that little thing that looks like this. You'll see it. It's very distinct. Chewable thing. Nick Shanks.
Could that be upside down?
What if you do a negative? What if I did a negative square root of x? What would happen there? All these would be their positives. You guys are killing me. You're not supposed to ask. Oh, let's see. What if x is what? 0, it's still 0. What if x is positive 1, I get negative 1. So you will get, this will be, if it's a negative x, you get this upside down thing that looks like this. But it's that still same thing, it's just a little, it's just upside down. Does that make sense? Which would be why you couldn't do the negative thing of that. Alright, so what do we have so far? You've got this thing, which is the x squared. You've got this thing, which is the square root of x. And now we're going to do this thing here, which is the absolute value of x. Anybody speculate as to what the absolute value of x is? What do you think the graph of that will look like? Nobody cares to speculate? Y equals the absolute value of x. The little goalpost things. And again, now you can pick any number for x and y. So let's just shoot some easy ones out there. We'll do 0 because that's easy. What would negative 1 be? Yeah, absolute value just makes things positive, so that's positive 1. What would positive 1 be? 1. What would be negative 4 would be 4. What would positive 4 be? How about negative 3? How about 3? Okay, here's what it's going to look like. Do a different color here. 0, 0. Negative 1, positive 1. Positive 1, positive 1. Negative 2, positive 2, positive 2, positive 2. Anybody seeing what's going to happen here? Positive 4, positive 4, negative 4, 4. What am I getting, ladies and gentlemen? Not a parabola. This actually is a straight, those are both straight lines. It makes a V shape with straight lines. Okay. The square root of x will give you a pointed corner looking thing. Okay, and again, it might be shifted in different places, but you're always going to get that thing. If it was negative square root of x, then it's just going to be the flip-flop of that where the thing points down. But it'll be a square corner. I believe it's a square corner. Is it a square corner? Is it always a square corner? Anybody following along with me?
Yep.
And I think, children, I think that is. Nuzo, you have something to say? Take a look in your books on page 182, 183. So those are the four or 3. Is that 4 or 3? We've got the x squared, the square root of x, the absolute value of x, and the, is that it?
Yeah.
Were those just the 3? I want to make sure I didn't miss one. I don't get a chance to talk about these very often. You see? Take a look at page 183 then, children.